Okay, today we're going to spend a little bit of time talking about vectors. I'm getting ready to do a unit in chapter 6 of our textbook, and we'll split this up into two pieces. The first 3 sections of the chapter are about vectors, just in general. So that's where we're going to start. So we'll start with what is a vector. A vector is a directed line segment. So when you think back to geometry, what a line segment is, this is like a line segment with direction. So there is a difference. Here's a line segment, and that is written like this. Then we have in geometry, we had this, which was a ray. That was ray AB. And what that meant is it starts at point A and just goes forever and ever and ever. But now we're talking about a combination of these two. Now we're talking about something that moves from point A to point B and stops. Unlike a ray, which goes on forever and ever, a vector has an initial point, a starting point, and an ending point. So it has direction, but it also has length. So it has direction, but like a segment, it is measurable. So we have a vector that is a certain length in a certain direction. That's what a vector is by definition. So we're going to work through some notes now. I am in my notes 6.1, page 49 at the top it says. So if you don't have those yet, stop the video, go find those notes, either put them into Notability or pull them up, something, so that you can work along with us. Okay, so here we go. First problem says, here's point A, and here's point B, and we're going to find the vector from A to B. Now, you'll notice that this little symbol here does not have 2 arrows. Sometimes people put 2 arrows on there. I don't, because I'm trying to distinguish between a vector and a ray. If I put 2 arrows on there, to most of us, that would represent a ray, which means it goes on forever and ever. We're talking about the vector, the thing that looks like this. It starts here, stops here, starts at A, stops at B, and we're going to describe that motion. It's very, very simple. Just ask yourself this question. If you were standing on a number line at -1 and you walked to 3, so I'm looking at just the x's now. I'm going to have an x and a y. If I start at -1 and walk to 3, how many steps would I have to take? Well, certainly you could count those on your finger. You could count them on the blackboard. Or you could just subtract. What's 3 minus -1? 3 minus -1 is 4. So if you were counting from -1 to 3, and I'm not going to do this again, I'll do it this one time. Here's -1. Here's my number line. If I were counting, excuse me, how many steps, it would be 1, 2, 3, 4 steps. 3 minus -1. It doesn't matter to me how you figure that out. A lot of you are just going to say, oh yeah, -1 to 3 is 4. Some of you are going to struggle with that, and that's fine, but you got to be able to figure out that from from -1 to 3 is 4 steps. And then do the same thing with the y's. From 2 to 4 is how many steps. If you start at 2 and go to 4, how many steps is that? It's 2. Again, if you just want to subtract, that's okay. 4 minus 2. Now, this right here, these guys are called the vector coordinates, or sometimes we call it the directed distance. Now, I think the vector coordinates, I think that terminology makes a lot of sense because coordinates, that looks like a coordinate, and it describes the vector's movement. In getting from here to here, this vector went right 4 and up 2. So I'm going to draw a real quick picture of that. And again, I'm not going to do this for every problem, or it will take us months to get through all this. But if we actually plotted the point -1, 2. Oh, you know what? Why don't I use my grid board? Then maybe we can see a little bit better. Can you see that okay? All right, so here's the origin. So I'm going to plot the point -1, 2. So -1, 2 is going to be plotted right here. So there's point A. And then point B is 3, 4. So here's the origin. I'll make it a little darker. 1, 2, 3, 1, 2, 3, 4. There is point B. So here is a picture of the vector we're talking about, right there. Now, to get from point A to point B, we went over 1, 2, 3, 4, and up 2. See that? We counted over 4 and up 2. Those are the coordinates of the vector. Okay. All right, let's try the next one. Going across, point A is 2, 4, and point B is -1, 0. And we want to know the coordinates of vector AB. The coordinates of vector AB. So, starting at A, stopping at B. Now look, this one's going backwards. 2 back to -1. So that would be -3. We start at 2, we got to count backwards all the way to -1. Or, if you prefer, you can do -1 minus 2. That will give you -3. How about 4 to 0? 4 to 0, we're starting at 4, ending at 0, so we have backed up 4. Well, I said I wasn't going to do this, but I'll do one more on my grid board, and then that's absolutely it. Here's the origin, in case you can't see very well. So I'm going, my first point is 2, 4. So 1, 2, 1, 2, 3, 4. So there's A. And then my second point is -1, 0 right here. And that's point B. And now I got to get from A to B. So I got to go from A to B, like that. So to get there, I'm going to have to go over 1, 2, 3. And which way did I go left? I'm going to go left 3, and then down 1, 2, 3, 4. So I'm going left 3 and down 4. So that's why the coordinates of that vector are -3, -4. Okay, a couple more. This is problem C. All right, so here we go. We're coming up with the coordinates of vector AB. So we're going from -3 to +1. Think about that, from -3 to +1. Or, if you prefer, subtract 1 minus -3. But 1 minus -3 or -3 to +1 would be a movement of 4 steps in a positive direction. If you're ever worried about positive or negative, remember, if you're going bigger, if your number's getting bigger, 1 is bigger than a negative, then it's going to be a positive movement. Just like here, from -6 to 4, that's going to be a positive movement, and that's going to be 10. If you're confused, get out your number line and start counting, or get out your graph paper and start counting. It is going to be important, though, that you are able to find the directed distance or the vector coordinates pretty readily, because you're going to have to do that over and over again in lots of problems. Okay, one more. We want the coordinates of the vector. You're starting at 0, stopping at 6. So that would be 6 steps. You're starting at 1, stopping at 2. That would be 1 step. So the vector coordinates, or the directed distance, for problem D is 6, 1. Okay. Now the next section is kind of the same thing, except they're asking you to find 2 of them and decide if they make equal vectors or not. So let's start with, this is problem A, and let's start by just finding AB, because we've done several of those already. Let's find AB. So AB is the vector from 1 to 6, so that would be 5, and 4 to 2. Now be careful, 4 to 2 is going backwards, so that's going to be -2. When you start at 4 and end at 2, that's the equivalent of 2 negative. Now, in the same problem, you have a C and a D. Now, let's find CD. Do the same thing. The letters are different, concept's the same. So from 3 to 5, or shoot, from 3 to 8 would be 5. And from -1 to -3. Now, remember, you're going backwards to get from -1 to -3, so that's going to be -2 steps. Oh, look, they're the same. So question A said, is AB equal to CD? And the answer is yes. Why are they equal? Because they have exactly the same directed distance, the exact same coordinates. That makes them equal. That's how we know vectors are equal. They have exactly the same coordinates. All right, the next one. C -3, 1, and 0, 2. And then C is 4, 1. And D is 6, 4. Okay, here we go. This is our problem. And again, we just want to know if vector AB, whatever AB is it the same as CD? So that's going to be easy to figure. We just have to find the coordinates of the vectors. So here we go. AB, from -3 to 0. Don't get confused. You're going right, aren't you, on the number line? You're going from -3 to 0, so that's +3 steps. And then you're going from 1 to 2, so that's a +1. Again, if that is still bothering you, you need to draw it on a piece of graph paper or put it on a number line. Somehow you've got to figure out that from -3 to 0 is 3 steps in the positive direction. How about here? CD, 4 to 6. Well, that's 2. And 1 to 4, that's 3. 4 to 6 is +2. And 1 to 4 is +3. Well, guess what? Do they match? No. So for problem, this is problem B, not A anymore. This is problem B. For problem B, the 2 vectors are not equal because they do not have the same directed distances. One more of those. I know you're getting a little bored with it probably, but it's good practice. All right, here we go. From A to B, go ahead and figure that out. From A to B, I hope you got 6, 4, because -2 to 4, you're counting to the right, all the way from -2 to 4 would be 6 steps. Remember, you can always subtract 4 minus -2. And then negative 1 to 3 is 4. 3 minus negative 1. So that's how many steps. That's how we move from point A to point B. Okay, now what about CD? 6 to 12, that's 6. And 2 to 6, that's 4. So yay, we have another set of equal vectors. 6 to 12, that's 6, that's a difference of 6 steps. 2 to 6, that's 4. Awesome. Now, the next section or number 3, problem 3, introduces a new idea. But it also has an old idea. So let's start with the old idea first. We got 2 points, P, Q. And it says find the components. Now, a minute ago, I told you that those directed distances were called vector coordinates or directed distance. Well, they can also be called components. So all we're doing is exactly what we've been doing. We're going to find the ordered pair of numbers that represents the movement from P to Q. And that will be the components of the vector. So these guys right here, this right here is going to be called components, vector coordinates, or directed distance. All of those words mean exactly the same thing. Anytime you see the word components, you know you're talking about an X and a Y. Okay, so what is our X and Y? We're going from 3 to 4. That would be 1. And we're going from 1 to 2, so that would be 1. Those are the components of the vector. Now the new stuff. It says we want the magnitude. Now magnitude is simply a fancy vector word for length. So they are asking us, okay, if we have a vector that goes over 1 and up 1, which is what this vector does. It goes over 1 and up 1. Over 1 and up 1. How long is it? Well, there are a couple of different ways that you can think about this, but probably the easiest way is for you just to think about this little right triangle right here. We go over 1 and up 1. This would be the hypotenuse. The magnitude of the vector is the hypotenuse. How do we find the hypotenuse of a right triangle? You're right, we use the Pythagorean Theorem. So we would say 1 squared plus 1 squared equals, I'll call it, should I call it C? I don't know, C squared. Like A squared plus B squared equals C squared. So 1 plus 1 equals C squared. So the magnitude of that vector equals the square root of 2. Now, there is a notation for that. So let me back up and make sure everybody figured out where we got root 2. This vector, we figured out, went right 1 and up 1. So I just drew a picture of that. Right 1 and up 1. This is what it looks like. It goes right 1 and up 1. And if you go right 1 and up 1, then you have A squared, B squared, C squared. And 1 squared plus 1 squared is 2. So C is the square root of 2. Now, when we write our answer down, the way we express that is like this. Magnitude looks like absolute value. So when you see the vector inside absolute value, that means you are looking for its magnitude. So we would actually write our answer on the paper like this. The magnitude of the vector is root 2. The length of the vector is root 2. The symbol we use for magnitude looks like absolute value. All right, let's try another one. Same thing. This time my vectors, there they are. Those are my vectors. So I'm going to now find the coordinates and the absolute value or the magnitude. Okay? So here we go. First off, what are the coordinates of that vector? Well, we're going from P to Q, so -1 to 6 would be 7. 6 minus -1 if you do it that way. And then 0 to 1 is 1. So there are the components of the vector. That's the first part of the answer. There are the components. Now, what about the magnitude? Remember, we note that like this. This means magnitude. This means length. Well, if we come over here and just kind of sketch this real quick, this vector, if we drew 7, 1, it would go over 7 and up 1. Sorry about that. That's not a very straight line, but you get the idea. It's kind of hard sitting here to make that come out very well. I'll try one more time. No, that's even worse. You get the idea. Counted over 7 and up 1. So now I'm going to make a little right triangle. And I know I went over 7 and up 1. So now I'm going to find the length, because that's what this means. That means the length. So the length of that would be a squared plus b squared equals c squared. So 49 plus 1. So that length is going to be the square root of 50. 49 plus 1, Pythagorean Theorem. Now, the square root of 50, you know, breaks down, right? 50 breaks down. So instead of saying the square root of 50, we'll say 5 square roots of 2. And that is the magnitude of the vector. Well, let's try another one. It's -6, 2, 1, -3. This is problem C. Okay, you're probably getting pretty good at this. Step 1 is we got to find the coordinates of the vector, or the components, or the directed distance, whatever words you're using. So we're going from -6 to 1. -6 to 1. I hope you said 7, because 1 minus -6 is 7. And then from 2 to -3, watch it, that's going backwards. From 2 to -3 would be -5. So we have the vector whose coordinates are 7, -5. And now we got to find the magnitude of that. So we're going to count over 7. And down 5. So here we are down here, over 7, down 5. So, oh, lordy, lordy, lordy. So there it is. Okay, that's better. Over 7, down 5. Here's our vector. So I'm going to make my triangle. So my little right triangle here, I can count over 7 and down 5. I know that's negative, but it doesn't really matter because I'm going to square it anyway, right, when I do the Pythagorean Theorem. My job is to find the hypotenuse here. That's the magnitude. So 7 squared plus 5 squared is going to be my hypotenuse squared. So 49 and 25. So 74 equals c squared. So the length is going to be the square root of 74. Your magnitude is the square root of 74. Okay, one more, and then we're going to do something different. So we got one more chance to get this figured out here. Point P is negative 2, 4. And point Q is 6, 1. All right, so we're going to find our coordinates. So see if you can find those real quick. Going from P to Q. I hope you said 8, negative 3, because we're going from negative 2 to 6, so that's 8. And we're going from 4 to 1, that's back 3, or down 3. Now we need the magnitude. So we'll think about what this looks like. 1, 2, 3, 4, 5, 6, 7, 8 over 8, down 3. Make my little triangle. I'm coming over 8. I'm going down 3. So 8 squared plus 3 squared is going to be my c squared, my hypotenuse. So 64 plus 9, 73. So the square root of 73. Now remember, we've only hit one that reduced, but if you do have them, if they do reduce, you do have to reduce them. But 73 does not break down. Okay? All right. Now, let's look at the next section, which is a little bit different. A lot of the same ideas, but some just basic vector operations. So here is the first difference. You are given the coordinates. This is not a point. This is the actual vector. This is like the PQ that we had in the last problem. These are the components. And then we're also told that V is 2, negative 2. And W is 0, 3. So we're given all of that. And the first question says, find U plus V. Now, I wish we were together in person because I know you could guess this. You might think to yourself, oh my gosh, I've never done anything like this before and I don't have any idea. But if you were stranded on a desert island and the only way to get off was to take a guess at this, you would get it right. Because to add these two vectors together, we simply add their x's. So we're doing U and V. So we're looking at U and V now. This one and this one. We simply add their x's and add their y's. So that is the sum of U and V. While we are here, I'm going to give you another vocabulary word. In Vectorland, another way of saying sum is to say resultant. So when you add vectors together, like we did right here, the answer is often referred to as the resultant. So this right here is the resultant of vectors U and V. We added U and V together. We just did that x plus x, y plus y. Real simple. Real simple. Sort of like when you added matrices. You added numbers in the same spots. And that's what we're doing. And the resultant is called the sum. Now, the next problem, B, I'm going in order. So B says 3V. Now again, if you just took a wild guess, I know you would get it right. There is vector V. If we take 3 times V, that's going to be 6, negative 6. Because we do it just like you did with matrices. You take 3 times all the numbers in the vector. That 3, by the way, is referred to as a scalar, just like it was when we talked about matrices. Golly, so far you're thinking this is easy, and you're right, it is. Okay, the next one says this. Now stop, we just talked about this. What does this notation mean? That means magnitude. What does magnitude mean? Magnitude means length. Okay, so here's my vector, negative 3, 1. So some of you don't have to draw them anymore. Some of you have this figured out. But you can always draw it. Negative 3, 1. There's my vector, negative 3, 1. Left 3, up 1. I'm doing U. Make your triangle. This is 3, this is 1. You came left 3, up 1. So Pythagorean Theorem would say 3 squared plus 1 squared equals c squared. So it looks like the magnitude of that vector is going to be the square root of 10. The magnitude is simply the square root of 10. The next one says u plus 2v. Now, u is negative 3, 1. But before you can add these, the first thing you're going to have to do is double v, right? Take 2 times v. So 2 times v, take 2 times those. So that would be 4, negative 4. Now you're going to add them together. And we just talked about how to do that. We said we're going to add numbers that are in the same spots. We call those corresponding numbers. But we're going to add negative 3 and 4, so that'll be 1. And 1 and negative 4 would be negative 3. So the sum or the resultant of these two vectors is 1, negative 3. We are adding them, just simply flat out adding them. Nothing tricky, just adding. V minus W. Now this is our first one where we've done a subtraction. So V is 2, negative 2, and W is 0, 3. Now subtraction works just like addition. So we're going to take 2 minus 0, and that will give us 2. So once again, 2 minus 0. And then we're going to take negative 2 minus 3. Negative 2 minus 3, which will be negative 5. And that is the difference of vector V minus vector W. Okay. Now we have this. This is another one where I know you know this. Put a negative sign out in front. Guess what that's going to do? That's just going to take the opposite of all that. So the opposite of negative 3 would be positive 3. And the opposite of 1 is negative 1. So that is all there is to that one. All right. Now G looks a little bit tougher. What is going on here? Well, first of all, you remember what this means, right? These things mean magnitude. So this tells me I'm eventually going to be finding the length, right? But first, these are like parentheses. You got to do what's inside first. So before I do any magnitudes, I'm not going to be drawing a picture, doing Pythagorean Theorem and all that until I subtract. So the first thing I'm going to do is subtract. So U minus V will be negative 3, 1 minus 2, negative 2. That is U minus V. Negative 3, 1 minus 2, negative 2. Okay? Now, let's subtract. -3 minus 2. -3 minus 2 would be -5. And 1 minus -2 would be 3. -3 minus 2 and 1 minus -2. Now I have to find the magnitude. So again, if you want to draw a picture, that's fine. You don't need to. If we draw a picture, we're coming left 5 and up 3. So left 5 and up 3. And you know what? I'm going to take that negative out because I don't want you making a mistake with that. When you square it, it's going to be positive. So put the negative in if you want, but just make sure when you square it, it disappears. So we've got a squared plus b squared equals c squared. So it looks like 25 plus 9 or 34. So this is the square root of 34. And that is the answer to the question. So this right here, this is question number G, or letter G. G is the square root of 34. Now, I want to talk about this for a second because I think most of you have probably already noticed. When I do my magnitude, I've been drawing a picture every single time. But ultimately, to find my hypotenuse, to find my actual magnitude, what did I end up doing every time? Didn't I just square the first number, square the second number, add them up and take the square root? Now, again, I'm not trying to confuse you, but if you don't want to draw a picture every time, you certainly don't need to. Because if you want to find the magnitude, you just square the first one, square the second one, add them up and take the square root. That is how you can always find your magnitudes. And the last problem. Now again, this means we're going to be doing length, we're going to be doing magnitude, which means we will be doing the whole square, square, add them up and square root, the whole Pythagorean Theorem thing. But before we do that, we need to do 2u and then add that to w. So what would here's u. What would 2u be? 2u would be -6, This is 2u right here. 2u. And then we're going to add that to w. So we're going to add, so add this, add -6 and 0. Add 2 and 3. So that's 2u plus w, and that's what I get as my answer. That's the resultant of these two getting added together. So I need to find the length of this vector. It's inside the absolute value, so I need to find its magnitude. So you can go ahead and draw a picture if you want. Left 6, up 5. I'm not going to draw a picture anymore. First of all, I'm bad at it. And second, I don't need to, because I know that magnitude is always going to be the square root of the first number squared plus the second number squared. And those are always going to be positive because you're always squaring. So don't ever, ever, ever have a negative under there. You're squaring. So what is that? Can I add? That's the square root of 61. So the answer to question H is the square root of 61. All right. Number 5. We're still in 6-1. We're on problem number 5 now. This is a big section. It's got a lot of stuff in it. So let's set our number 5 going here. What does it say? Find a unit vector. All right, there's a new vocabulary word. Find a unit vector. A unit vector is a vector whose length is 1. Now, guys, you've done enough of these. The magnitude of this vector is not 1. The magnitude of this vector, remember, some of you are drawing pictures, over 2, up 1. Oh, I guess I didn't do a very good job. See what I mean? I'm just not very good at this. Over 2, up 1. So we square, add them up and take the square root. So the magnitude of that vector is root 5. Pythagorean Theorem, square the first one, square the second one, add them up and take the square root. This is not a unit vector. Unit vectors have a length of 1. This thing has a length of the square root of 5. So how do we make it a unit vector? Well, you aren't going to believe this. It is incredibly simple. We simply take the coordinates of the vector and divide by the magnitude. In other words, we just put both of these over the square root of 5. So your unit vector for this vector would be negative 2 over root 5, comma, 1 over root 5. Now, a lot of times I get mad when you leave radicals in the bottom. I'm not going to here because some of the work that you might do with vectors, it's easier to leave them like this. However, I will insist that you simplify anything. So if your radical does reduce, I need you to reduce it. And then if there's any canceling you can do in the fraction, I want you to do that. But this one, root 5 does not reduce, and obviously there's nothing there that cancels. So that would be the answer to the problem. Perfect. If you want to go ahead and rationalize it, some of you, are just creatures of habit, which is great, and you just want to make sure you take care of all the details. So if you want to multiply top and bottom by root 5 and end up with this, that is absolutely perfect too. That is fine. You don't have to do that, but if you want to do that, that would be great. Okay, so bottom line, I've done a lot of jabbering. How do we find a unit vector? We simply divide the coordinates of the vector by the magnitude of the vector. So when I give you the next one, which is 6, negative 2, if you want to make that a unit vector, which is your job in this problem, then you are going to have to do what? Find the magnitude of the original. So what is the magnitude of the original? Remember, you can either draw it, write 6 down 2, or you can just know that to find the magnitude, you're going to square the first one, square the second one, add them up, and take the square root. So 36 plus 4, and I'll draw this one more time. This is the last one I'm going to draw. But over 6, down 2. See, what happens is when you do the Pythagorean Theorem, you end up squaring 6, squaring 2. I don't need a picture to do that. Now, this is a situation where it does reduce, so we're going to have to reduce it. So 40 breaks down. Remember, you're looking for groups of 2, so that would be 2 times the square root of 10. So then to find our unit vector, we take the original coordinates we had and divide each one by 2 over root 10. Now, a minute ago, I told you I expected you to do all simplification in terms of canceling. So that's going to happen in this problem because you have a 6 over a 2. So the 2 is going to go into 6 and leave you with 3 over root 10. And here the 2's are going to cancel and leave you with negative 1 over root 10. So once again, we had 6 over 2 root 10 and negative 2 over 2 root 10. You are expected to cancel. So 2 goes into 6 3 times, and 2 goes into negative 2 negative 1 time. So this is the answer to the question. Zero, 4. You're going to make it a unit vector. So the first thing you're going to do is find the magnitude of the vector itself. So the magnitude of the vector itself would be the square root of the first one squared plus the second one squared. Oh, the magnitude is just 4. Well, I told you I wasn't going to draw, but that just makes sense. Look, kids, if you plot 0, 4, this is what it looks like. It's straight up 4 units. So how long is that? It's 4. You just counted, you went sideways nowhere and went straight up 4. So its length is obviously 4. So how do we make it a unit vector? We take these coordinates and divide by the magnitude. So the unit vector would be 0, 1. That would be the answer to your question. Alrighty, one more of those. Let me give you a minute to try it on your own. The vector we're talking about is negative 3, negative 4. So you're going to make that a unit vector. So remember what that means. That means you're going to find the magnitude of the original vector. Right here, find its magnitude. And then you're going to divide both of these numbers by that magnitude. So hopefully you haven't forgotten how to find magnitude. But to find magnitude, we simply square the first one, the first number. We square the second number. We add them together and take the square root. So the magnitude would be the square root of 25, which is just 5 this time. So we're going to take our original coordinates and divide them by the magnitude we got. So our unit vector is negative 3/5, negative 4/5. And that's the answer to the question right there. That's your unit vector. Okay, I think that's it for today. So hope you're having a great day, and I hope to see you soon.